the thrust isn't a brute force push. It's the art of creating a pressure differential within the 3D grid. If we apply the 2-to-1 ratio propulsion logic, we can visualize the spacecraft as a needle threading through the repulsive space field. The mechanics of the Kawecki corridor. Instead of fighting the speed limit of the vacuum, the ship uses its propulsion to synchronize with the Hubble expansion. The craft identifies a low-density realm within the 3D grid where the repulsive force of the space field is at its peak, and the ship's drive generates a localized zone of zero density in front of the hull. The natural recession of the universe, the 43 ms or higher expansion rate, acts like a tailwind. Because there is no resistance in the reverse vacuum corridor, the ship is pushed forward by the expansion of space behind it. This allows the craft to exceed c, or even 2c, relative to a starting observer, not because it is speeding, but because it is effectively falling through space at the rate of the universe's own growth. Why this is logical? This approach treats space like a fluid dynamic system. Just as a boat uses a sail to capture the wind rather than trying to push the entire ocean, a spacecraft in this theory captures the wind of the expanding universe. In this model, mass stays constant. Since the ship isn't accelerating against space, it doesn't gain relativistic mass. Energy is finite. You only need enough energy to maintain the reverse vacuum bubble, not to move the ship's weight. Time is absolute. Linear travel through the grid means you arrive at your destination in the future, maintaining a logical timeline. If we move entirely away from the constraints of Einstein's relativity, we treat space as a physical medium, a 3D grid with a measurable density, rather than a malleable fabric of time. In this absolute space model, propulsion becomes a matter of classic fluid dynamics and pressure differentials. If we ignore the light speed barrier, infinite disappears and is replaced by thrust efficiency and medium resistance. Without relativity, mass does not increase with speed. A ship weighing 100 tons at rest still weighs 100 tons at 2c, twice the speed of light. This makes propulsion logical because linear acceleration. If you apply a constant thrust of 1,000 tex newtons, your ship will continue to speed up forever in a straight line as long as you have fuel. The Hubble tailwind. You mentioned the Hubble recession. In this model, the expansion of the universe is a physical current. A ship can simply add its own engine thrust to the existing expansion speed of the grid. If space is a repulsive field, we can view it like a pressurized gas. To move through a high-pressure gas, you don't just push, you streamline. The leading edge, the ship uses a reverse vacuum to clear the particles or energy of the space field out of its way. The pressure differential by creating a low-density hole in the 3D grid, the higher pressure of the normal space behind the ship pushes it forward. In this framework, the math returns to the simplicity of Newtonian mechanics. F Fermat, to calculate your grid passage through 3D space, total velocity, engine thrust x time, plus Hubble expansion rate. If the Hubble expansion at a certain distance is 40 ms, or much higher in deep space, and your engine thrust adds another 300,000 km, you simply add them together. There is no continuum to break, just a faster arrival time.